Hello students, I am Sanjana Kavatagi, Assistant Professor, Department of Computer Science and Engineering, AITM Belgavi. Let us continue with the video lectures on computer organization. We have started with the interface circuits, that is from module number 3, input on output organization. So in the previous video we have studied about interface circuits, parallel port. Okay, so in that you have studied input interface circuit as well as output interface circuit, an example for both of them. So in this video we shall move to serial port. In this video we shall study about serial port. So basically a serial port is used to connect the processor to IO devices that require the transmission of data one bit at a time. So the key feature of this interface circuit for serial port is that it is capable of communicating in a bit serial fashion on the device side and in a bit parallel fashion on the bus side. So just see here, it is bit serial fashion in the sense bits will be sent in bits will be sent serially. Okay, so that is called as bit serial fashion, that is on the device side, but it will be bit parallel fashion on the bus side. Bit parallel is nothing but bits will be sent parallelly. Bit serial is nothing but bits will be transmitted serially. Okay, so the key feature of the interface circuit for the serial port is that it is capable of communicating in bit serial fashion on the device side and it is in bit parallel fashion on the bus side. So the transformation between parallel and serial formats is achieved with the shift registers that have parallel access to the capability. As I told, it is in the serial fashion from the device side, but when it comes to bus, it becomes parallel. So how this transformation is done is this will be achieved by the shift registers which have the parallel access capability. So shift registers have the capacity of parallel access. They are capable of accessing the bits parallelly. So shift registers are used for this transformation, that is from parallel to serial or serial to parallel formats. So for this block diagram of a typical serial interface is given in the figure. So this figure is 4.37 from the textbook, you can refer. Okay, so this includes the familiar data in and data out registers, which you already know what they are, and then we have the shift input shift register that accepts bit serial input from the IO device. Okay, so when all the 8 bits of the data have been received, the contents of this shift registers will be loaded in parallel to the data in register. Okay, so it will be bit serial input from the IO device, and when it will be loaded onto the data in register, they will be loaded in the parallel fashion. Similarly, output data in the data out register are loaded into the output shift register, from which the bits are shifted out and sent to the IO device. So this is how the transformation of serial fashion to parallel fashion or parallel fashion to serial fashion is happening. So you can see in the figure that is a serial interface. We have the input shift register, and then we have data in register and data out register, and then output shift register. We also have status and control block, okay, which is receiving the clock as well as it is transforming the transmission. It is doing the transmission of the clock. And then we have chip and register select, wherein we have multiple control lines, okay, like my address, rs1, rs0, read write signal, ready signal, accept signal. We shall study these in detail. And we have the bits like d0 to d7. These are nothing but the parallel bits. Okay, the part of the interface that deals with the bus is the same as in the parallel interface that we have studied before. So the status flags sin and sout serve the similar functions. Okay, the SN flag will be set to 1 when the new data are loaded into the data in. So then it will be clear to 0 when the processor reads the contents of data in. So when the data is loaded, Sin will be 1. Sin will become 0 when the contents of data in will be read by the processor. So as soon as the data are transferred from the input shift register to the data in register, the shift register can start accepting the next 8-bit characters from the IO device. Okay, so as soon as the bits will be moved to data in register from the shift register, so then immediately the shift register can start accepting the next 8-bit characters from the IO device. The SOT flag indicates whether the output buffer is available or not. So it is clear to 0 when the processor writes new data to the data out register, and it will be set to 1 when the data are transferred from the data out into the output shift register. Okay, here you can see just see the data out will be clear to 0 when the processor writes the new data into the SOut flag will be clear to 0 when the data is written into the data out register, and it will be set to 1 when the data is transferred from the to the data out will be 0, and it will be 1 when the data is transferred from the data out into the output shift register. So the double buffering is used here in the input as well as output. So that is very important here. So a simpler interface could be implemented by just turning the data in and data out into shift registers and eliminating the shift registers that are given in the figure. So however, this could impose an awkward restriction on the operation of the IO interface. So after receiving one character from the serial line, the device cannot start receiving the next character until the processor reads the contents of the data in. So as soon as one character is received, the device cannot receive another character until the processor is reading the contents or the data within the data in register. So thus a pause would be needed between two characters to allow the processor to read the input data. So once one character is fetched, it should be given some time until the processor reads that particular character. So that's why with the double buffer, the transfer of the second character will be it can begin as soon as the first character is loaded from the shift register into the data in register. Okay, so that is why double buffer will be used. So thus, provided the processor reads the contents of the data in before the serial transfer of the second character is completed, so the interface can receive a continuous stream of serial data. Okay, so provided the processor is reading the contents of the data in register before the serial transfer of the second character is done or it is completed, the interface can receive a continuous stream of serial data. Okay, so for this an analogous situation occurs in the output path of the interface. But because it requires a fewer wires, serial transmission is convenient for connecting the devices that physically that are physically far away from the computer, because if we are sending the bits serially, less wires will be required. But the same case, if we are sending the bits parallelly, how many bits are there, those many lines would be, or those many wires would be required. So the speed of transmission often is given as the bit rate. Okay, that is the bits transmitted per second. That is nothing but the bit rate. So it depends, that bit rate depends on the nature of the devices that are going to be connected. So to accommodate a range of devices, a serial interface must be able to use a range of clock speeds. So this is given in the figure 4.37 from the textbook, which allows a separate clock signals to be used for input and output operations for increased flexibility. Okay. So because serial interfaces play a vital role in connecting the IO devices, several widely used standards have been developed. So a standard circuit that includes the feature of our example that is shown in the figure is known as the Universal Asynchronous Receiver Transmitter, which is called as UART. Okay, it is universal asynchronous receiver transmitter. So it is intended for the use with the low speed serial devices. The data transmission is performed using the asynchronous start stop format, which we will be studying in the future. Okay, so to facilitate the connections to communication links, a popular standard known as RS-232C was developed. Okay, so this is one example for the serial bus. Okay, so to facilitate the communication links or the connection between the various devices, a popular standard which is called as RS-232C was being developed. Okay, this we will be studying in the further chapters. So this is about serial ports.